Hello and welcome to SmartElectro Academy. In this complete professional solar training course, you will learn the full solar home system from beginner level to technician level. This includes system design, panel selection, inverter and battery sizing, protection devices, earthing, wiring, testing, maintenance, and real fault fixing. This course is specially designed for electrician students, technicians, and homeowners who want to reduce electricity bills safely. We will use real technical explanations and diagram-based understanding. By the end of this training, you will be able to design and install a solar power system confidently. Please subscribe to SmartElectro Academy and let us begin.
What is a solar power system?
Welcome to an insightful look into solar power systems, a revolutionary way to harness the sun's energy for your home. A solar power system converts sunlight into electrical energy using photovoltaic cells inside solar panels. When sunlight strikes the panel, DC electricity is produced, initiating the energy generation process. This DC power is either stored in batteries for later use or converted into AC power using an inverter for immediate home consumption. Solar energy offers numerous benefits. It's clean, renewable, silent, and becomes free after the initial installation. With correct design and maintenance, a solar system can operate efficiently for over 25 years, providing long-term energy independence. The entire process can be visualized as a seamless flow: sun to panel, then DC power to inverter, converting to AC power for your home. Embrace the power of the sun and discover how solar energy can transform your home's energy future.
Types of solar systems.
Choosing the right solar system for your home requires understanding the different types available. There are three main types: off-grid, on-grid, and hybrid, each with distinct features. Off-grid systems operate independently, relying solely on stored battery power. While offering independence, they have high battery costs and risk outages if storage is low. On-grid systems connect to your utility, sending excess energy back to the grid. These are cost-effective, but provide no power during grid outages. Hybrid solar systems combine grid connection with battery storage. This setup provides reliable backup power and optimizes energy use, reducing bills. For homes in areas with unreliable grids, hybrid systems offer both savings and continuous power. Hybrid options provide a balanced and resilient solution for many homeowners.
Main components of a solar system.
Hello, I'm El Cientifico Sonriente, and today we're exploring the main components of a solar energy system, designed to harness the sun's power efficiently and safely. At the heart of any solar system are the solar panels, which convert sunlight into direct current, or DC, electricity using photovoltaic cells. Next, the hybrid inverter is crucial. It transforms the DC electricity from the panels into alternating current, AC, which is what most homes use, and also manages battery storage and grid interaction. Batteries are essential for storing any excess solar energy generated during the day, allowing you to use it when the sun isn't shining, like at night or on cloudy days. Safety is paramount, and various protection devices are integrated into the system. These include the DC MCB, AC MCB, RCCB, and Surge Protection Device, or SPD. The DC MCB and AC MCB protect against overcurrents in direct and alternating current circuits, respectively, preventing damage to equipment and ensuring electrical safety. The RCCB, or Residual Current Circuit Breaker, detects and trips when there's an imbalance in current, offering critical protection against electric shock. A Surge Protection Device, SPD, safeguards the system from voltage spikes caused by lightning or other electrical disturbances, protecting sensitive electronics. Other vital components include solar cables for efficient power transmission, MC4 connectors for secure and waterproof connections, and an earthing system for grounding. Finally, a changeover switch allows you to seamlessly switch between grid power and your solar system, providing flexibility and energy independence. Each of these components ensures the safe and efficient operation of your solar energy system. Missing any protection device may lead to fire, electric shock, or equipment damage. Understanding these parts is key to appreciating how solar power works. Thank you for joining me on this illuminating journey into renewable energy.
Load calculation.
Welcome, future solar enthusiasts. Today, we're diving into a crucial step for any home solar system: calculating your energy load. Understanding your home's energy needs is the foundation for designing an efficient and reliable solar power system. Without an accurate load calculation, you risk an undersized system that won't meet your demands, or an oversized one that costs more than necessary. It's all about balancing your energy consumption with your solar production for optimal performance and savings. Let's break down how to calculate your home's energy load step by step, ensuring your solar system is perfectly tailored. First, list all home appliances with their watt ratings: lights, fans, TV, fridge, iron, and so on. Next, add up the total watts for all appliances you plan to power simultaneously. For example, let's say your total load equals 1500 watts. Then, divide this total wattage by your home's voltage, typically 230 volts, to find the current in amperes. This correct load calculation is vital. It prevents inverter overloading, which can damage your equipment and lead to costly repairs. It also safeguards your battery bank from premature degradation, ensuring a longer lifespan and consistent power supply. By carefully calculating your energy load, you're investing in the safety, efficiency, and longevity of your entire solar power system. Empower your home with solar energy, knowing you've laid the groundwork for a sustainable and reliable future.
Battery capacity calculation.
Hello, solar enthusiasts. Today, we're diving into a crucial aspect of off-grid living: calculating your solar battery capacity. Proper battery sizing is essential for ensuring you have reliable power when the sun isn't shining and for extending the lifespan of your battery bank. Our first step is to determine your total daily energy consumption, which is the sum of all your appliances' power ratings multiplied by their usage time. Next, consider how many hours of backup power you need. This depends on your location's sunlight availability and your personal energy security preferences. Multiply your total load in watts by your required backup hours to get your total watt hours, or WH. For example, 1,500 watts times 5 hours equals 7,500 watt hours. Now, we convert watt hours to amp hours, or Ah, by dividing by your system's voltage, typically 24 or 48 volts. So, 7,500 WH divided by a 24-volt system gives us 312.5 Ah. This is your baseline battery capacity. Finally, add a 20 to 25% safety margin to account for inefficiencies, future expansion, and to prevent deep battery discharge, which can shorten battery life. This safety margin ensures your system can handle unexpected demands and keeps your batteries healthy for years to come. Correct battery sizing is paramount for both long backup duration and the longevity of your entire solar power system. By following these steps, you can confidently determine the right battery capacity for your solar energy needs. Thank you for joining me, El Científico Sonriente, on this journey to understand solar battery capacity. Stay tuned for more insights into making your solar system as efficient and reliable as possible.
Solar panel types.
Considering solar for your home? Understanding the different types of solar panels is key to making the best choice for your energy needs. Solar energy offers incredible benefits, from reducing your carbon footprint to significantly lowering your electricity bills. Let's explore the options. First, we have monocrystalline panels, known for their high efficiency and premium quality. They are easily recognizable by their uniform, dark black appearance. These panels are made from a single crystal of silicon, offering superior performance in limited spaces and boasting the longest lifespan among panel types. Next are polycrystalline panels. These are a more cost-effective option, often distinguished by their blue, speckled appearance. They are made from multiple silicon crystals melted together, making them slightly less efficient than monocrystalline, but still a great value. Finally, thin film panels offer flexibility and affordability. They are lightweight and can even be integrated into various surfaces. While they have the lowest efficiency and shortest lifespan, their versatility and lower cost can be advantageous for specific applications. To help you visualize the differences, here's a quick comparison of monocrystalline, polycrystalline, and thin film panels. For most residential homeowners, monocrystalline panels are often the recommended choice due to their superior efficiency and long-term performance. However, the best panel for you depends on your specific needs, budget, and available roof space. Consider all factors carefully. Embrace the power of the sun and make an informed decision to power your home sustainably. Your solar journey starts now.
Series and parallel panel connections.
Understanding solar panel wiring is crucial for any DIY installer, especially when deciding between series and parallel connections. In a series connection, solar panels are linked end to end, much like batteries in a flashlight. This configuration adds up the voltage of each panel, resulting in a higher overall system voltage. Higher voltage is beneficial for longer cable runs, as it minimizes energy loss and allows for more efficient power transmission to your inverter. Conversely, a parallel connection links panels side by side, connecting positive to positive and negative to negative. This setup increases the total current output while maintaining the voltage of a single panel. Increased current is ideal for systems requiring more power at a lower voltage, often used in smaller off-grid setups or when specific inverter requirements dictate. Let's visualize these differences. Here, you can see how series wiring connects panels sequentially, boosting voltage, while parallel wiring connects them in unison, boosting current. A critical aspect for DIY installers is matching your solar array's voltage to your inverter's maximum power point tracking, or MPPT, voltage range. This range is crucial for your inverter to operate efficiently and extract the maximum power from your solar panels. An incorrect combination, where the array's voltage falls outside the inverter's maximum power point tracking range, can severely damage or even destroy your inverter. Always consult your inverter's specifications and plan your wiring carefully to ensure compatibility and system longevity.
Solar panel installation rules.
Welcome, DIY solar installers. Before diving into your project, understanding these key rules for solar panel installation is absolutely crucial to ensure maximum efficiency in energy production and the highest standards of safety for both yourself and your home. First, ensure your panels are strategically placed to receive direct sunlight throughout the entire day, remaining completely free from any shadows or shading that could interfere with performance. Even a small shadow, such as one cast by a tree branch, chimney, or nearby structure, can drastically reduce your panel's overall power output, impacting the efficiency of the whole array more than you might expect. Optimizing the tilt angle of your panels is vital for peak performance. It must be precisely adjusted based on your specific geographic location and latitude to capture the maximum amount of sunlight year-round. The mounting structure supporting your panels must be incredibly strong and constructed from durable, rust-proof materials designed to withstand harsh weather elements like rain, wind, and snow over the long term. This robust design ensures long-term stability and safety for your setup, effectively protecting your investment from corrosion, weathering, and structural fatigue that could compromise the system. Equally important, the roof itself must be structurally sound and fully capable of bearing the significant additional load from the entire solar array without risking damage or failure. To avoid any risks, always consult with a qualified professional, such as a structural engineer or roofer, to thoroughly assess your roof's integrity and load-bearing capacity before beginning any installation. By carefully adhering to these essential rules, you will successfully achieve a safe, efficient, and long-lasting solar power system that reliably powers your home for many years.
Inverter working principle.
At its core, an inverter is a crucial device in any solar power system, taking the direct current, or DC, generated by solar panels. It then transforms this DC into alternating current, or AC, which is the standard electricity used to power homes and businesses, and what the electrical grid operates on. A more advanced type, the hybrid inverter, offers even greater versatility in managing your solar energy. Beyond converting DC to AC, it intelligently manages the charging and discharging of energy storage batteries. Furthermore, it seamlessly handles the interaction with the electrical grid, deciding when to draw power from it or feed excess solar energy back into it. Integral to optimizing solar panel performance are MPPT charge controllers, which stand for maximum power point tracking. This technology constantly adjusts the electrical load to ensure solar panels operate at their peak efficiency, extracting the absolute maximum power available from the sunlight. It's crucial to understand that you should never connect solar panels directly to batteries without a charge controller. Doing so can lead to overcharging, which severely damages the battery and poses significant safety risks, including fire. The inverter's internal flow is a complex yet efficient process, converting raw solar energy into usable electricity for your needs. Understanding these components ensures a safe, efficient, and reliable solar power system for your home or business.
Correct connection order.
Welcome to this essential guide on connecting your solar inverter system correctly. Understanding the proper sequence is crucial for both safety and the longevity of your equipment. A common mistake can lead to instant damage to your inverter, a costly component, and any solar setup. Let's ensure you avoid these pitfalls. The very first step in establishing your solar power system is to connect the batteries to the inverter. This provides the necessary stable power source for the inverter's initial boot up. Ensure all battery connections are secure and correctly polarized before proceeding. This foundational step prevents power surges or incorrect voltage delivery. Once your batteries are safely connected, the next critical step is to integrate your solar panels into the system. These panels are the primary source of energy generation. Connect the solar panel array to the inverter's designated solar input terminals. Always double-check your wiring to match the inverter's specifications for voltage and current. Finally, with the power generation and storage components in place, you can connect the AC output of the inverter to your changeover switch and distribution board, or DB. This final connection allows the generated solar power to be safely distributed throughout your home or facility, powering your appliances and reducing reliance on the grid. Remember, following this correct connection order, batteries first, then solar panels, and finally AC output, is paramount to prevent damage and ensure efficient operation. A wrong sequence can instantly damage your inverter, leading to costly repairs or replacements. Always prioritize safety and precision in your solar installations. Thank you for watching. For more detailed guides and expert tips on solar power systems, be sure to subscribe to our channel.
Performance optimization.
Have you ever wondered how the sun's powerful energy can light up your home? A solar power system makes this possible by converting sunlight directly into usable electricity. At its core, a solar power system relies on photovoltaic cells, typically found in solar panels, which are designed to capture sunlight. When sunlight strikes these cells, it excites electrons, generating direct current, or DC, electricity. This is the initial form of power produced. This DC power has two main paths. It can either be stored in robust battery banks for later use, or it can be immediately converted for household consumption. For most home appliances, we need alternating current, or AC, electricity. This is where an inverter comes in, transforming the DC power into AC. Once converted, this AC electricity powers your home, running everything from lights to appliances, seamlessly integrating into your existing electrical system. Beyond powering your daily life, solar energy is remarkably clean and renewable. It harnesses the sun's endless power without creating harmful pollution. This means a significantly reduced carbon footprint and a healthier planet for everyone. It's a sustainable choice for our future. Once installed, a solar system is a long-term investment. With proper maintenance, it can provide free electricity for more than 20 years. This longevity translates into substantial savings on your energy bills and a reliable, independent power source for decades to come. Embrace the power of the sun and discover how a solar power system can transform your energy consumption, offering a bright and sustainable future.
Battery types.
Lead-acid, tubular, and lithium are three common battery types, each with distinct characteristics. Lithium batteries generally last longer and charge faster, offering superior performance for many modern applications. However, lithium batteries are typically more expensive upfront compared to other options. In contrast, lead-acid batteries are a more budget-friendly choice, widely available and reliable for many uses. Despite their lower cost, lead-acid batteries often require regular maintenance, such as checking electrolyte levels. Tubular batteries, a type of lead-acid, offer enhanced durability and efficiency, especially for deep discharge cycles. Regardless of battery type, always use appropriate fuses to protect your system from overcurrents and potential damage. Additionally, insulated lugs are crucial for preventing short circuits and ensuring safe, secure electrical connections. Understanding these differences helps in selecting the right battery for your specific needs, balancing cost, performance, and maintenance.
Protection devices.
Earthing systems are crucial for solar panel installations, ensuring both safety and the longevity of your equipment. Also known as grounding, earthing connects specific solar system components to the earth, providing a safe path for stray currents. This vital connection prevents electrical hazards like electric shocks, lightning strikes, and power surges, protecting both people and property. Proper earthing is essential for the panel frames, the inverter body, and the entire AC system to function safely and efficiently. It safeguards your valuable solar panels, inverters, and batteries from damage due to overvoltage and electrostatic discharge. For effective protection, the earth resistance must be carefully measured and maintained below 5 ohms. This low resistance ensures that excess voltage from surges, such as lightning, is safely directed into the earth, preventing costly equipment damage. Let's look at a typical earth pit system, a common and effective earthing technique. This diagram illustrates how a ground rod is driven into the earth, often surrounded by specialized chemicals like bentonite clay to enhance conductivity. Copper or galvanized iron strips then connect the solar panel frames and inverter to this earthing rod, completing the protective circuit. Regular inspection and maintenance of your earthing system are vital to ensure its continued effectiveness and compliance with safety standards. By implementing proper earthing, your solar panel system will operate safely and efficiently, protecting both people and your investment for years to come.
Changeover and grid operation.
Understanding how solar power integrates with the electrical grid is crucial for efficient energy management in your home. At the heart of this integration are changeover switches, which seamlessly manage the flow of power between your solar panels and the utility grid. These switches ensure a continuous power supply, allowing you to utilize solar energy when available and draw from the grid when needed. Hybrid inverters play a vital role, offering advanced control over your energy usage. They come with various operational modes, providing flexibility to prioritize your energy sources. One common setting is Solar Priority Mode, where your home primarily uses electricity generated by your solar panels. Grid Priority Mode, on the other hand, means your system will draw power from the utility grid first, supplementing with solar only when necessary. For those with battery storage, Battery Priority Mode ensures that stored energy is utilized before drawing from the grid or even directly from solar. These flexible modes allow homeowners to optimize energy consumption, reduce electricity bills, and enhance energy independence. Let's visualize the power flow in a hybrid mode setup where all these components work together. This diagram illustrates how solar, battery, and grid power are intelligently managed by the hybrid inverter to meet your home's demands. Such systems provide a robust and adaptable solution for modern energy needs, ensuring reliability and sustainability. By understanding changeover and grid operation, you can make informed decisions for your solar power system.
Final system testing.
Welcome to this essential guide on the final system testing of a solar installation, ensuring everything operates safely and efficiently. Our comprehensive testing process begins with verifying critical electrical parameters to guarantee system integrity. First, we accurately measure the DC voltage from the solar panels, confirming it aligns with design specifications. Next, we check the battery voltage, ensuring the energy storage system is correctly charged and functioning within its optimal range. We then verify the inverter output voltage, which is crucial for confirming that the AC power supply to the property is stable and correct. A critical safety check involves testing the residual current circuit breaker, or RCCB, to ensure it trips correctly under fault conditions. Earthing continuity is also meticulously checked to provide essential protection against electrical shocks and system damage. Once these initial electrical tests are complete, we proceed to gradually connect the electrical loads. This allows us to observe the current draw under real-world operating conditions, ensuring the system handles demand efficiently. Monitoring the current draw helps us confirm that the solar installation is performing optimally and safely under load. Each step of this final testing phase is vital for the long-term reliability and safety of your solar power system. By following these rigorous procedures, we ensure your solar investment delivers consistent, clean energy for years to come. Thank you for joining us to understand the importance of thorough final system testing in solar installations. For more information on solar energy and installation best practices, please visit our website.
Fault our inverter not turning on.
Welcome to troubleshooting an inverter that won't power on, a common issue fixed with simple checks. Before complex repairs, check the most frequent causes of an unresponsive inverter. First, check battery voltage. Low battery is the top reason inverters won't start. Ensure voltage is 12.5 volts or higher for a 12-volt system. If low, recharge or replace the battery. It lacks power. Next, inspect fuses. Inverters have internal and external fuses against overloads. Blown fuses show broken filaments or discoloration. Replace with correct amperage. Check terminal connections. Loose or corroded ones prevent power flow. Fasten cables securely and clean corrosion with a wire brush. Verify battery polarity. Wrong connections stop the inverter or damage it. Connect positive to positive, negative to negative. Recharge weak batteries or replace if they won't hold charge. These steps fix most inverter power failures. Follow to diagnose issues. Safety first. Disconnect power before electrical work. These checks will get your inverter running. Thanks for watching.
Fault, no solar charging.
Welcome to our guide on troubleshooting common issues with your solar charging system. If your solar panels aren't producing power, start by checking the DC MCB or miniature circuit breaker. Ensure all MC4 connectors are securely fastened, as loose connections can interrupt the power flow. Next, use a multimeter to verify the solar voltage directly from your panels. This step helps confirm if the panels themselves are generating the expected voltage. Dirty panels can significantly reduce efficiency, so a thorough cleaning might be necessary. Inspect your panels for any shadows cast by trees, buildings, or other obstructions. Even partial shading can drastically impact the overall performance of your solar array. For more complex issues, consult your system's manual or a certified solar technician. Regular maintenance and prompt troubleshooting ensure your solar system operates at peak efficiency. By following these steps, you can keep your solar power flowing smoothly.
Fault a low backup time.
Experiencing frequent power outages or devices dying too quickly. Low battery backup time is a common issue, but understanding its causes is the first step to a reliable power supply. Many factors can contribute to your battery system failing to hold a charge as long as you need it to, leading to frustration and unexpected downtime. One primary cause is simply having undersized batteries for your energy demands. If your battery bank isn't large enough to handle the load, it will deplete much faster than anticipated. Another significant factor is the age of your batteries. Just like any component, batteries degrade over time, losing their capacity to store and deliver power efficiently. This degradation is clearly illustrated by the battery aging curve, which shows a gradual decline in a battery's maximum charge capacity over its lifespan, even with proper care. Finally, excessive night load can drain your batteries unexpectedly. Devices left on overnight, even in standby mode, can cumulatively consume a surprising amount of energy. The most straightforward solution to undersized systems is to increase your battery capacity. Adding more batteries or upgrading to higher capacity units ensures you have ample power reserves. For aging systems, regularly testing and replacing weak or old batteries is crucial. A single failing battery can compromise the performance of an entire bank. Implementing smart energy management, like using timers for non-essential devices or upgrading to energy-efficient appliances, can also significantly reduce your night load. By addressing these common causes and implementing these solutions, you can significantly improve your battery backup time and ensure a more reliable and consistent power supply.
Fault, inverter tripping.
Is your inverter constantly tripping, leaving you without power? Don't worry, it's a common issue, and we're here to help you understand why and how to fix it. The primary culprits behind a tripping inverter are typically an overload or a short circuit. Understanding these two issues is key to effective troubleshooting. An overload occurs when too many appliances draw more power than the inverter can safely supply. This triggers the inverter's overload protection logic to prevent damage. To address an overload, begin by safely disconnecting heavy power-consuming appliances one by one. Observe if the inverter resets after each removal. Now, let's talk about short circuits, which are often more serious and require careful attention. A short circuit happens when an unintended low-resistance path allows current to bypass the normal circuit. This sudden surge of current can cause significant heat and damage, which is why inverters have robust short circuit protection. It's designed to instantly cut power. Checking for a short circuit involves inspecting your wiring for any frayed cables, loose connections, or damaged insulation. Always ensure the inverter is off before inspecting. Safety is paramount when dealing with electrical systems. If you're unsure or uncomfortable, always consult a qualified electrician. Remember, start by reducing the load for overloads and meticulously check your wiring for short circuits. These steps will help you diagnose and resolve most tripping issues. With a little patience and these troubleshooting tips, you'll have your inverter running smoothly again in no time. Stay safe and powered up.
Fault: electric shock on panel body.
Welcome to this essential guide on electrical safety, focusing on the critical role of proper earthing. Earthing, or grounding, provides a safe path for electricity to flow into the earth in case of a fault, preventing dangerous electrical shocks. Without proper earthing, a fault can cause the metal casing of an electrical appliance or panel to become live, posing a severe electrocution risk. Imagine a scenario where an internal wire touches the metal body of an electrical panel due to damage or wear. If there's no earthing, anyone touching that panel could receive a severe electric shock, as their body becomes the path to the ground. This is why a missing earthing connection is incredibly dangerous and must be addressed immediately. Upon discovering such a fault, the first step is to immediately shut down the power supply to the affected panel. Next, a qualified electrician must install proper earthing to ensure the panel is safe for operation. Proper earthing ensures that fault currents are safely discharged, protecting lives and equipment. Always prioritize electrical safety by regularly inspecting your earthing systems and addressing any issues promptly. Stay safe and ensure your electrical installations are always properly earthed.
Solar safety rules.
Welcome, professionals. Today, we're focusing on critical solar safety rules to ensure a secure working environment for everyone involved in solar panel installations and maintenance. Always isolate both DC and AC circuits before starting any work on solar panels or related equipment, treating all wiring as live. Proper grounding and bonding of all metal parts are fundamental to prevent electrical shock and mitigate electrical faults. Using properly insulated tools rated for electrical work is essential, and they should be regularly checked and maintained for safety. Always wear appropriate personal protective equipment, including insulated gloves, safety glasses, hard hats, and fall protection harnesses when working at heights. DC-rated miniature circuit breakers, or MCBs, are critical for protecting solar power systems from overcurrents and short circuits. These MCBs are specifically designed to handle the unique characteristics of DC current, which is more difficult to interrupt than AC. Properly ventilated battery rooms are necessary to prevent gas buildup, as batteries can emit toxic or explosive gases. Battery management systems, or BMS, should be used to monitor performance and prevent overcharging, ensuring safe operating temperatures and charge limits. Having appropriate fire extinguishers, such as Class C, readily available is vital for emergency preparedness. Solar installations must incorporate disconnect and emergency shut-off mechanisms to allow for quick deactivation of the system in emergencies. A visual diagram summarizing these key safety rules can reinforce information and ensure everyone is aware of critical protocols. By adhering to these guidelines, professionals can significantly mitigate risks and maintain a safe, productive environment for all solar energy operations.
Maintenance tips.
Maintaining your
Basic cost estimation.
Considering solar panels for your home, understanding the basic cost estimation is crucial for making an informed decision. Several key factors influence the total cost of a solar panel system, starting with the panel count and overall system size in kilowatts. The type and quality of panels, such as monocrystalline, polycrystalline, or thin film, along with the inverter rating, whether string, microinverters, or hybrid, also play a significant role. Additionally, the size of your battery storage, if you choose to include one, and the complexity of the mounting structure contribute to the overall expense. Don't forget costs associated with permits, inspections, and your specific geographical location, which can impact installation complexity and local regulations. While the initial investment for solar panels can seem substantial, the long-term savings and benefits are truly significant. A typical cost breakdown reveals that solar panels account for 18%, while the inverter and system equipment make up 19% of the total cost. Installation labor is around 7%, permits and inspections are 5%, and soft costs, which include customer acquisition and overhead, represent a substantial 51%. Beyond the initial outlay, solar energy offers substantial long-term savings through reduced electricity bills and greater energy independence. Various incentives, such as the federal solar tax credit, state rebates, and net metering programs, further enhance the financial viability of solar installation. These incentives can significantly offset the upfront costs, making solar power a more accessible and attractive option for homeowners. While costs vary, investing in solar panels is a smart move towards a sustainable future and substantial financial returns.
System life expectancy.
Understanding the lifespan of your solar energy system components is key to maximizing your investment and ensuring long-term energy independence. Let's explore the expected life expectancy of solar panels, inverters, and batteries, crucial elements for any homeowner considering or already using solar power. Solar panels are incredibly durable, designed to withstand various weather conditions and provide reliable energy for decades. With proper installation and minimal maintenance, you can expect your solar panels to last well over 25 years, often continuing to produce power beyond that. Next, we have the inverter, a vital component that converts the DC electricity from your panels into AC electricity for your home. Inverters typically have a lifespan of 8 to 12 years, though this can vary based on the type and quality of the unit. It's important to factor in potential replacement costs for inverters when planning your long-term solar energy budget. Finally, let's talk about solar batteries, which store excess energy for use when the sun isn't shining. The life expectancy of solar batteries ranges from 3 to 10 years, heavily depending on their type, usage patterns, and how well they are maintained. Regular monitoring and adherence to manufacturer guidelines can significantly extend the life of your battery storage system. To summarize, solar panels offer 25+ years, inverters typically last 8 to 12 years, and batteries range from 3 to 10 years depending on type and care. Understanding these lifespans helps you make informed decisions about your solar investment and plan for future maintenance or upgrades. Embrace solar energy with confidence. Knowing the longevity of your system components contributes to a sustainable and cost-effective future.
Design mistakes to avoid.
Welcome, installers and technicians, to a crucial discussion on avoiding common design mistakes in battery installation. One of the most critical errors is undersizing batteries, which can severely impact system performance and longevity. Always ensure your battery bank is appropriately sized to meet the system's energy demands, preventing premature failure and inefficiency. Skipping essential protection mechanisms, such as fuses and circuit breakers, leaves your system vulnerable to dangerous overcurrents and short circuits. Proper protection is non-negotiable for safety and to safeguard your investment against potential damage. Mixing old and new batteries, or different types, creates imbalances that reduce overall capacity and accelerate degradation of the entire bank. For optimal performance and lifespan, always use batteries of the same age, type, and capacity within a single system. Overloading the inverter is another common pitfall, leading to overheating, reduced efficiency, and potential failure of critical components. Ensure your inverter's capacity matches or exceeds the maximum expected load to maintain stable and reliable power delivery. Understanding these common design mistakes is the first step towards flawless battery installations. By adhering to best practices, you ensure the safety, efficiency, and longevity of every system you install. Thank you for your dedication to excellence in battery installation.
Standard wiring color codes.
Understanding standard wiring color codes is crucial for electrical safety and proper installation in any setting. These universal standards prevent confusion, reduce the risk of electrical hazards, and ensure compatibility across different systems and regions. Let's begin with the red and brown wires, which are typically designated for phase or positive connections. These carry the live current from the power source, making them critical components in any electrical circuit. Next, we have the blue and black wires, commonly used for neutral or negative connections. Neutral wires complete the circuit, providing a return path for the current back to the power source. Finally, the green-yellow wire is universally recognized as the earth or ground connection. This wire is a vital safety feature designed to protect against electric shock by providing a safe path for fault currents. Adhering to these color codes is not just a recommendation. It's a fundamental practice for ensuring safety and reliability in all electrical work. Always double-check your connections and consult local regulations to guarantee compliance and prevent accidents. By understanding and applying these standard wiring color codes, you contribute to a safer electrical environment for everyone. Stay safe, stay informed, and always prioritize correct wiring practices.
Fire and emergency safety.
Ensuring fire and emergency safety for your inverter is crucial for protecting your home and loved ones. Always keep your inverter in a dry, well-ventilated area, away from any moisture or humidity that could cause electrical hazards. Flammable materials, such as curtains, paper, or chemicals, must be kept at a safe distance to prevent accidental ignition from heat or sparks. Using the correct fuses is vital. Never bypass or replace them with fuses of a higher rating, as this can lead to overheating and fire. These small components play a huge role in preventing electrical overloads and potential fire incidents. For emergencies, always have a CO2 fire extinguisher readily accessible near your inverter setup. CO2 extinguishers are safe for electrical fires as they displace oxygen without leaving conductive residue, unlike water-based extinguishers. Consider a fire safety layout diagram for your inverter installation, clearly marking the inverter's location and extinguisher placement. This visual guide helps everyone in the household understand emergency procedures and quickly locate safety equipment. A well-thought-out diagram can significantly reduce response time during an emergency. Regularly inspect your inverter for any signs of damage, loose connections, or unusual smells, which could indicate a problem. Staying vigilant and proactive about maintenance can prevent minor issues from escalating into dangerous situations. By following these simple yet critical safety guidelines, you can ensure the safe operation of your inverter. Prioritize safety, educate your household, and always be prepared for any emergency. Your safety is paramount.
Final conclusion and call to action.
Welcome back to SmartElectro Academy. We've covered essentials for safe, efficient solar integration into your home. Solar systems are a reliable investment, offering energy independence and big cost savings. Longevity starts with design tailored to your needs, south-facing orientation, and proper panel sizing. NABCEP certified pros following NEC 2023 codes ensure top safety and performance. Heat protections, DCAFCIs, rapid shutdown, surge protection, and grounding. These prevent fires, rare at 0.0007% per NFPA data, keeping your home safe. Biannual cleaning and annual inverter checks boost output and extend system life. These steps let solar safely power your home for 25 to 40 years. NREL says panels degrade just 0.5% yearly, retaining 92% capacity after 25 years. A 7-kilowatt system offsets 100 to 150 tons of CO2 and saves $20,000 to $40,000 over its life. Zillow shows solar boost property value by 4.1%. If this empowered you for safe solar, like this video. Share with friends tackling home electrification. Subscribe to SmartElectro Academy for solar, EVs, and smart homes training. Comment questions below. I guarantee personal replies. Thank you for choosing SmartElectro Academy. Power your future safely.